What is this learning curve? This learning curve is otherwise called as experience curve. For what is this curve going to be useful? It is applicable to an industry. Which is applicable? The learning curve effect is applicable to monotonous type of industries. What do you mean by monotonous type of industries? They do the same work again and again. They do it in a repetitive manner. There is no refinement in work. The same work, early morning, you wake up, you brush your teeth, you have your bath, you repeat the work again and again, correct? So it is a monotonous type of industry to which this learning curve is applicable. What happens with learning curve? With learning curve, the time taken to perform a particular task will reduce based on experience. The time taken to perform a task or to produce a particular unit will reduce with experience. So what happens? Once the individual gains the maximum expertise, he will finish the task in the least possible time. Okay. So once the laborer achieves expertise in the task, he will finish the task in the least possible time. He will finish the task in the least possible time. So the learning curve effect aims at reducing the labor cost for the particular job. Okay. So what happens? The learning curve effect aims at reducing the labor cost for a particular task. Okay. For this, what are the assumptions made? The learning curve effect will apply for doubling of output only. Assumption is the learning curve effect will apply to doubling of output. Okay. So just to give you an example, if I am new to a particular task, I am handling the task for the first time. Okay. If I am doing the task for the first time and I take 1 hour to complete the task, the second time I know how to handle things at least to some extent. Suppose it says 80% learning effect. I will finish the task in 0.8 hours itself. If suppose the learning effect is 80%, I will finish the task in 0.8 hours itself. Next, for the first time, the second time I told you will apply to doubling of output. Then for the fourth time, not the third time, for the fourth time, I will finish the task at 0.64 hours. So likewise, when I am performing the task repeatedly, I will reach the least possible time to perform the particular task. How is that time arrived? From the first time taken for the first unit, multiply with the learning effect. You will get the time taken for the second unit. This is 1 into 2. Then 2 into 2 will be 4. Then next will be, it will not be 4th time. Next will be 8th time. 4 into 2 will be 8. For the 8th time, the time taken will be 0.64 hours into 80% of it. So likewise, the time taken for the task will reduce based on the learning percentage. Based on the learning percentage, in your intermediate level, you might have studied only for 80%, if at all you studied. Here we will apply various percentages. Okay. So for an 80% learning effect, which is quite common, for that learning effect, you will apply the time taken for the units by multiplying the output 2 times, only for doubling of output. Immediately, you might think, What about the third unit? What about the fifth, sixth, and seventh unit? From the fourth unit, I cannot directly jump over to the eighth unit. There will be intermediary units. Then after the eighth unit, into 2, it will be the 16th time. Which means you cannot jump over from the 8th time to the 16th time directly. You can increase step by step only. Correct? Then what happens to the 9th time to the 15th time? For the 9th time to the 15th time, you cannot apply the learning effect directly. Instead, we will be using logarithm and anti-logarithm. Okay. So 0.512 into 80% will be 0.4096 hours and so on. Okay. The learning curve is a downward sloping curve where you have the units on the x-axis and the time taken on the y-axis. Okay. For the first unit, you are taking the maximum time. For the second unit, your time taken will reduce. For the fourth unit, your time taken will reduce. For the eighth unit, your time taken will reduce. Then for the 16th unit, then for the 32nd unit, and so on. So it is a downward sloping curve. And at one point, the line will go parallel to x-axis, which is the minimum time required to perform the task. So the line will not touch x-axis. The line will not reach 0 because you need a minimum time to perform the task. So once when the line goes parallel to x-axis, that time will be the minimum time required to perform the task. So I told you the learning curve effect will apply for doubling of output. So 1 into 2, then 2 into 2, then 4 into 2, then 8 into 2, 16 into 2, 32 into 2, and so on, where you can apply the respective learning effect percentage. What if it is the units between the second and fourth, or between the fourth and eighth, or between the 8 and 16, or between 16 and 32? What if it is units in between, for which to apply the learning effect or to calculate the time taken, you have a formula y is equal to ax to the power of b, where y is the average time taken. Y is the average time taken to produce X units. Okay. A is the time taken for the first unit. A is the time taken for the first unit. X is the number of units. And B is the learning coefficient. B is learning coefficient. Okay. At 80%, the value of B is minus 0.322. At 80%, the value of B is minus 0.322. Okay. These are all rules where y is equal to ax to the power of b. I will tell you how this minus 0.322 is arrived. I will tell you. Okay. Y is equal to ax to the power of b, where y is the average time taken to produce x units. A is the time taken for the first unit. X is the cumulative number of units. And B is the learning coefficient. 99% you will apply 80% learning effect. Some cases you may apply 70% learning effect. Sometimes you may apply 50% learning effect also. It depends on the question. I will tell you how this minus 0.322 is arrived. 80% is log of 0.8. Log of 0.8 to the base log 2. Okay. I will tell you using a normal calculator how to find log values. Log values using normal calculator. I will tell you how to calculate log values using normal calculator. So what you are supposed to do is feed the number in your calculator. So whatever is the number, if you want log of 0.8, first type 0.8 in your calculator. Okay. Have you all done? 0.8 in your calculator. Take square root 15 times. Take square root 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Are you getting 0.99999319021? Are you getting that? Yes, minus 1. Minus 1. You will be getting minus 0.0000680,979. Correct? Are you getting that number? Then divide by 0.4070271. Divide by 4070271. Are you getting minus 0.0969? Minus 0.096907. Are you getting that number? Right. For log 2, repeat the steps. Take 2 in your calculator. 2 in your calculator. Take square root 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think I missed the number. 1 minute. 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Minus 1. Divide by 0.4 times of 0, 70271. Are you getting 0.30102574? Divide the numerator and the denominator. Anyway, the answer will be minus. You should get minus 0.322. Check if you are getting that. 0.0969075 divided by 0.30102574. Are you getting 0.3219, which is 0.322? Did you understand how that 0.322 is arrived? 80% can be written as 0.8. Okay. Log 0.8 to the base of log 2. How do you take log using normal calculator? I have written. Feed the number in your calculator. Take square root 15 times minus 1. Divide by this constant. This constant you have to remember. Divide by the constant, which is 0.4070271. You get log of 0.8, which is 80% learning effect, which is minus 0.322. Now, did you understand? Right. Okay. So, suppose in the further sums, if they are asking you for log values, in this chapter, it is full of logarithm and anti-logarithm only. When they are asking you that way, you have to do like this. Okay. How do you take anti-log then? Log is log of 0.8, or maybe I will write example. I will give you an example. I will give you an example. Log of log of 2. With experience, I know the number. Log of 2 is 0.3010. How did you get this value? You have fed 2 in your calculator. Square root 15 times minus 1 divide by minus 1 divide by 0.000070271. That will give you 0.3010. Correct? So, should you get anti-log of 0.3010 as 2? Should you get this? Anti-log of 0.3010 should be 2. Yes or no? Yes. So how do you take anti-log of that number? It is ulta process of logarithm. Here you have divided. So now multiply. Multiply with 0.4070271. Here you have subtracted. So here you add. Here you have taken square root. So here you will multiply and equal to 15 times. When you are going in the reverse order, you will get 2. So this is this way. This is this way. Okay. Just check in your calculator 0.3010. Multiply with 0.4070271 plus 1 into equal to 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Are you getting to 1.999? Is that 2? That's all. To take a log, if you are going in the downward approach, to take an anti-log, go in the upward approach. Okay, ba? Right. So now coming to the sums. I told you the formula y is equal to ax to the power of b. When will that formula y is equal to ax to the power of b apply? Y is equal to ax to the power of b will apply to units which does not fall within the doubling range. Which does not fall within the doubling range. What is that doubling range then? Doubling range will be 1, 2, 4, 8, 16, 32, 64, 128 and so on. Everywhere multiply by 2. Okay. If they say find the time taken for 16 units. If they say find the time taken for 64 units. You can directly apply the learning effect percentage. But what if they say find the time taken for 20 units? What if they say find the time taken for 40 units? It doesn't fall within the doubling range at all. In which case, you will apply the formula y is equal to ax to the power of b. For this, you need to know certain logarithmic rules. Certain logarithmic rules you need to know. Log of m into n is equal to log m plus log n. Do you know that? Log of m by n is equal to log m minus log n. Log of m to the power of n is equal to n log m. These rules we will apply. Okay. So when y is equal to ax to the power of b, taking log on both sides, log y is equal to log of ax to the power of b. So what happens here? This will be log of a plus log of x to the power of b. This will be equal to log a plus b log x. So log y is equal to this. After finding that number, my intention is to find y. What is y? Y is the average time taken. My intention is to find y. So after finding the log y value, I will take anti-log of that number to get y. Did you understand so far? When two values are multiplied, a into x, it is log a plus log x. When one value is to the power will go to the left side as a constant. So it becomes b log x.